Something is sending powerful bursts of radio energy across the cosmos, and nobody knows what it is. For over a decade, astronomers have been picking up these mysterious signals. Flashes of radio light so bright they dwarf anything we've ever detected in our own galaxy. They last mere milliseconds, yet pack more energy than the sun produces in an entire day. They come from billions of light years away, piercing through the darkness of space to reach our instruments here on Earth. And despite years of research, cutting-edge technology, and some of the brightest minds in astrophysics working on the problem, we still can't say for certain what's creating them. These phenomena are called fast radio bursts, or FRBs, and they represent one of the most perplexing mysteries in modern astronomy. Are they natural cosmic events, the dying gasps of collapsing stars, or something else entirely? Could they be signals from advanced civilizations trying to communicate across the vast distances of space? The truth is, we simply don't know, and for years we couldn't even be sure they were coming from space at all. The story of fast radio bursts begins roughly a decade ago at CSIRO's Parkes Radio Telescope in Australia. Astronomers were scanning the skies when they detected something unusual: brief, intense pulses of radio energy that didn't match any known cosmic phenomenon. These weren't like the steady radio emissions from pulsars or the predictable patterns from quasars. They were different, sudden, violent, and then gone, disappearing as quickly as they had appeared. Swinburne University of Technology would later describe these signals as millisecond duration intense pulses of radio light that appear to be coming from vast distances. But here's what makes them truly extraordinary. They are about 1 billion times more luminous than anything we have ever seen in our own Milky Way galaxy. Let that sink in for a moment. 1 billion times brighter than the most powerful radio sources in our cosmic neighborhood. Whatever is producing these bursts is unleashing an almost incomprehensible amount of energy in a fraction of a second. Over the following years, more than 20 examples of FRBs were detected, each one adding to the growing puzzle. But with each new detection came more questions than answers. Where were they coming from? What could possibly generate that much energy in such a short time? And perhaps most importantly, were they even real? Not everyone was convinced that fast radio bursts were the cosmic mystery they appeared to be. From the moment FRBs entered the scientific conversation, skepticism followed. Many scientists doubted the outer space origins of the signals completely, suggesting instead that what researchers were detecting wasn't coming from distant galaxies at all, but from much closer to home. The alternative explanation was far less exciting, but potentially more plausible: earthly interference. Our planet is awash in radio signals, from satellites, cell phones, microwave ovens, and countless other sources of electromagnetic radiation. Could these mysterious cosmic signals actually just be terrestrial noise? Were astronomers chasing ghosts created by our own technology? This wasn't an unreasonable hypothesis. Radio astronomy is notoriously challenging precisely because of interference from human-made sources. Distinguishing between a genuine signal from space and radio pollution from Earth requires extremely careful analysis. And when you're talking about signals that last only milliseconds, the margin for error becomes even smaller. The debate created a fundamental problem for FRB research. Without definitive proof that these signals originated beyond our atmosphere, the entire field existed in a state of uncertainty. Were scientists studying a genuine cosmic phenomenon, or were they being fooled by terrestrial interference? The answer would require better technology and a more sophisticated approach to detection. Enter Manisha Caleb, a PhD candidate working across multiple Australian institutions: Australian National University, Swinburne University of Technology, and the ARC Centre of Excellence for All-Sky Astrophysics, known as CAAS. TRO. Caleb and her team took on the challenge of settling the debate once and for all. They needed to prove definitively that fast radio bursts were coming from outer space, not from sources on or near Earth. The breakthrough came through a combination of advanced detection methods and a crucial piece of technology, the Milonglo telescope. But before we get to that, it's important to understand why proving the cosmic origin of FRBs had been so difficult in the first place. The problem lay in the limitations of conventional radio telescopes. Most radio astronomy is conducted using single-dish telescopes, massive parabolic dishes that collect radio waves from space. While these instruments are incredibly sensitive, they have a significant weakness when it comes to pinpointing the origin of signals. As Chris Flynn from Swinburne University of Technology explained, conventional single-dish radio telescopes have difficulty establishing that. Transmissions originate beyond the Earth's atmosphere. Think of it this way. A single-dish telescope is like trying to figure out where a sound is coming from while wearing earmuffs and standing in a noisy room. You might hear something, but determining whether it came from across the street or across the galaxy is another matter entirely. Without the ability to triangulate or verify the source of a signal, astronomers were left with tantalizing detections but frustrating ambiguity. The Milonglo telescope provided the solution researchers had been searching for. This isn't your typical radio telescope. With a collecting area of approximately 18,000 square meters, that's roughly 194,000 square feet, it's a beast of an instrument. Its field of view spans 8 square degrees on the sky, giving it the ability to monitor a substantial portion of the cosmos simultaneously. But size and coverage weren't the Milonglo telescope's only advantages. The real breakthrough came from its unique architecture. Unlike single-dish telescopes, the Milonglo telescope's design inherently prevents it from detecting signals that originate within Earth's atmosphere. This architectural feature essentially acts as a built-in filter, screening out terrestrial interference automatically. This was exactly what Caleb and her team needed. With the Milonglo telescope, they could detect fast radio bursts with confidence, knowing that any signal picked up by the instrument had to be coming from beyond our atmosphere. It was the smoking gun that would finally settle the debate about FRB's origins. Using the Milonglo telescope, Caleb's team successfully detected fast radio bursts and confirmed what many had suspected but couldn't prove. The mysterious bursts of radio waves that astronomers had been hunting for the past decade definitely do come from outer space. The signals weren't terrestrial interference, satellite glitches, or microwave ovens. They were genuine cosmic phenomena, originating from unimaginable distances across the universe. But confirming that FRBs come from space was only part of the puzzle. The next question was, where in space? Could the team narrow down the location of these mysterious transmissions? According to data from the study, the signals appear to be coming from the direction of the constellations Puppis and Hydra. These constellations, visible from the southern hemisphere, provided at least a general direction for the source of the bursts. But even with this information, we're still talking about vast regions of space containing billions of stars and countless galaxies. Pinpointing the exact source would require even more precise observations. With the cosmic origin of fast radio bursts confirmed, the focus has shifted to perhaps an even more intriguing question: what's causing them? The sheer energy involved in producing these bursts rules out many conventional explanations. We're talking about events that release as much energy in a few milliseconds as the sun produces in an entire day. That's not something that happens easily or often in the universe. Several theories have been proposed, each with its own supporters and skeptics. Some astronomers suggest FRBs could be caused by magnetars, neutron stars with incredibly powerful magnetic fields that can trigger massive energy releases. Others propose they might be the result of colliding neutron stars or black holes, cosmic catastrophes that could generate the kind of energy signatures we're detecting. Then there are the more speculative theories. Could fast radio bursts be artificial? Could they be signals from advanced extraterrestrial civilizations, perhaps using focused radio beams to propel spacecraft across interstellar distances? While most scientists are cautious about jumping to such conclusions, the possibility can't be entirely dismissed. After all, we're detecting signals of extraordinary power coming from across the cosmos. Until we know for certain what's creating them, everything remains on the table. The confirmation that fast radio bursts originate from outer space marks a significant milestone in our understanding of these phenomena, but it's far from the end of the story. In many ways, we're still at the beginning. Each answer we find seems to generate new questions, new mysteries that demand investigation. Why do some FRBs repeat while others appear only once? What determines the intensity and duration of these bursts? Are they associated with specific types of galaxies or cosmic environments? And perhaps most tantalizing, could there be different types of FRBs produced by entirely different mechanisms? The work of Caleb and her team has opened the door to a new era of FRB research. With the cosmic origin confirmed, astronomers can now focus their efforts on detection, cataloging, and ultimately understanding these mysterious signals. Advanced telescopes and detection networks are being deployed around the world, each one adding to our ability to capture and analyze these fleeting cosmic whispers. As our technology improves and our observation networks expand, we're likely to detect more fast radio bursts, gather more data, and slowly piece together the puzzle of what's creating them. But for now, the universe is keeping its secrets. Somewhere out in the cosmos, something is sending powerful bursts of radio energy across billions of light years of space. We've confirmed they exist. We've narrowed down their general direction. But what they are, why they exist, and what they might tell us about the universe remains one of astronomy's greatest unsolved mysteries. The signals continue to arrive, brief flashes of radio light in the darkness, each one carrying a message we're only beginning to learn how to read.